Hey guys, welcome to another video for Math 7a, and this time we're going over Chapter 2, Section 3, Simplifying Variable Expression. Okay? But before we do anything simplifying, let's talk about the later half of this word, variable expression. Let's review what is a variable expression. Variable expression is a sentence that consists of a number, a variable, and at least one math expression. So an example of that is, here we have 4 plus x. That is a variable expression. Another example is 4 plus x minus 2 plus y. Okay, that is a variable expression. Okay, so as long as it has a number, a operation, and a variable, we have a variable expression. Another one is 12 divided by x. That's a variable expression. It has a number, it has a operation, division, and it has a variable x. Okay, the variable can be any letter. It doesn't have to be x and y, but we'll probably use x and y a lot of times. Now let's talk about multiplying with variables. So how do we multiply numbers with variables? How do we write multiplying with variables? A lot of people think that when we write multiplying with variables, we write it like this: 4 times x, 4 dot x. Okay, but that's not how we're actually supposed to write multiplying with variables. When you have 4 times x, what you're supposed to actually write is 4x. That's it. There's no multiplication symbol between them, just a number and a variable together. So once you see a number and a variable together, automatically assume, oh, we're multiplying those. Another example is x times y. You're not supposed to write it like this. You write it like this, xy. That's how you multiply variables. Now, why do we need to write it like this? Well, we'll get to that later. Any questions? Okay, so before we can simplify expression, let's talk about combining like terms. We need to learn combining like terms. Okay? So here we have our expression 4y minus 3xy plus x minus 9. Okay, that is an expression. And there's a multiplication between 4 times y, 3 times x times y, things like that. Okay. Now let's talk about the word term from the like term. What does the term mean? Well, term basically means something that is separated by a plus or minus. So in our expression 4y minus 3xy plus x minus 9, how many terms do we have? Okay, now say your answer to yourself, and the actual answer is 4. We have 4 terms. 1, 2, 3, 4. 4 terms. So let's list them out. You have 4y minus 3xy, x, and 9. Okay, those are your terms. Now you're gonna ask yourself your question this: which of the 4 terms as shown here is different? Well, It's 9, right? 9 is the most different. Why 9? Well, 9 is the only number, only term without a variable. All three of them has a variable, only 9 doesn't have. So that is the variable term. That's the difference. So what does this tell us? It tells us that there's actually two terms, a variable term and a constant term. Variable terms are basically terms with variables, and constant term are terms with no variables. It's just self-explanatory. Okay? If you have a variable, that's a variable term, and if you have no variable, that's a constant term. Now, constant terms are just constant numbers. We already know constant numbers because you guys have been doing math for 7 years. But variable terms, on the other hand, is something new. So let's talk about variable terms. There's actually parts of a variable term. Every variable term has something called coefficient and a variable part. So the coefficient, so what is a coefficient? What is a coefficient? Coefficient is simply the number part of the variable term. Okay? So here we have 4y. The coefficient of 4y is 4, and the variable part of 4y is y. Now let's do the same thing with the other examples. Here we have negative 3xy. The coefficient of that is negative 3, and the variable part is xy. How about x? What is the coefficient of that? Well, think of this. The variable part of x is x, right? But what is our coefficient? Well, the coefficient is going to be 1. Okay? Remember this lesson from identity property. 1 times x is equal to x. Okay? So instead of writing it as 1 times x, you can write it as x. That's why when you have x, it's supposed to be as if you have an x as a variable term, your coefficient for that is 1, and the variable part is x. Now let's move on to negative x. The coefficient of negative x is actually negative 1, and the variable part is x. Okay, not 0. A lot of people think, oh, the coefficient of this is 0. But if you multiply 0 with any number, you'll get 0, not x. So that is not your coefficient. So here we have an expression. A like term are basically term with the same variable part. So in our expression, we have x, xy, yz, and y. As you can see, all 5 terms doesn't have any, they don't share the same variable part, so there's no like terms. Now let's have an example. Here we have 13ab plus 4 minus 3ab minus 10. First thing first, let's find the like terms. You circle the like terms with the sign in front, okay? So let's start with 13ab. Is there any like terms with 13ab? Well, let's look at other terms. 4 doesn't have any ab, so those two are not like terms. Let's move on to the next term, minus 3ab. Do they share the same terms? I mean variable part? One has ab and the other has ab. So yes, they share a variable part, which means those two are like terms. Now, by the way, all constant terms are automatically like terms. So 4 and minus 10 are like terms. Okay, LT means like terms. Now let's try a bigger, longer expression. 7y to the second power plus 2xy minus 8 plus 9yx minus 4y minus 12. Again, find the like terms. So let's start with 7y squared. Does y to the second power appear anywhere else? No. The y squared doesn't appear anywhere else. You might say, oh, how about this? 4y. Well, this has a 2 on it. This one doesn't have a 2 on it. So that means they are not the same. So 7y squared is by itself. Now let's move on to the next term. 2xy. Well, 8 doesn't have one. How about 9yx? Well, if you look closely, they share the same letters, right? X and X and Y. But the position is wrong. This one is XY and the other one is YX. So are they like terms? And the answer is, surprisingly, yes, they are like terms. Now you might be wondering, huh? They're not the same. Now my question is, do you guys remember what I told you? What is the operation between 9, y, and x? Do you guys remember? Do you guys remember the operation between y and x? It's multiplication, right? You're multiplying them. So it's actually 9 times y times x. Now, do you guys remember a property of multiplication that allows you to move around numbers? Starts with a C. It's commutative property. Commutative property says that you can rearrange this as 9 times x times y. Okay? So that means 2xy and 9yx are what we call like terms. Now let's move on to minus 8. Is there any other constant numbers? Yes, it's minus 12. So we also combine those two numbers together. I mean, those two are also like terms. Now how about minus 4y? Is it like terms with any other terms? No. So those are the two like terms we have. Okay, hopefully no confusion. If you do have questions, you can type in the chat, I can answer it. But if there's nothing, let's move on. Let's move on to the final part, or not final part, to the combining like terms. Combining like terms means, how do we combine like terms? Well, terms can be combined by adding or subtracting the coefficient of the like terms, okay? So do you remember what is the coefficient again? The coefficient of the terms are the number parts. Okay, let me change my pen. This is the coefficient, this is the coefficient, this is the coefficient, this is the coefficient. So what we're adding is the number part of the like terms, and the variable part, the letters, doesn't need to change, okay? So let's start with a small example. Here we have 6c plus 9c. Okay, are they, how many terms do we have? We have two terms. Okay, are those two terms like terms? Yes, they both share the same variable part, c. So that means we can combine them. How do we combine them? Well, we're going to add 6 and c. Why add? It's because of this. 6 plus c gives you 6 times 9, 6 plus 9 gives you 15. And then the variable part is going to be c. Now you might be wondering, huh? I don't get it. Well, imagine this. 6 carrots plus 9 carrots, okay? Let's say you have 6 carrots and you bought 9 carrots. How many carrots do you have in total? Well, you have 15 carrots, okay? That's how you're going to say it, right? You're not gonna say you have 15 carrots, because there's no such vegetable because there's no such thing as carrots, or there's no such thing as carrots to the second power, okay? There's no such thing. So just leave it as is, carrots. Okay, there's no such thing as 15 carrots squared. So just leave it as 15c. Now let's move on to the next part, 13m minus 5m. Again, they have the same, there we have two terms, and they are the same like terms. They both share m. So that means we're going to subtract 13 minus 5, which gives you 8. And the variable part is m. Again, you have, think of this as 13 marbles, and you gave 5 marbles away. How many marbles do you have left? You have 8 marbles. Okay. If that's one way to imagine adding or subtracting like terms. Now let's try something a bit harder. 3a plus a. What do we have? What's your answer? Okay. Well, I see a lot of people giving me 3a a, or 3a squared, or 3a. That's it. However, okay, so I see some of you guys don't get it. So let's put it in words. This means we have 3 apples, and then how many apples is this? It's an apple. Let's say you have 3 apples and you get an apple more. How many apples do you have in total? You have 4 apples. Okay, so that means 3a plus a gives you 4a. Okay, if you recall, a is simply 1 times a. Okay, identity property. Now let's try something harder. 6x plus 2 plus 4. Okay, now we're going to find terms for 6x. Like terms with that is plus x. Is there any more like terms? Yes, it's 2 and plus 4. Those are like terms. Now we combine them. 6x plus x is 7x plus 2 plus 8, 2 plus 4 is 8, or my bad, 7x plus 6. Now you might be wondering, where the heck did I get that? Uh, where the he- where did I get that addition sign? Well, here's the thing. Once if you here's the if you circled all of the terms and you combine them together, that means your sign is plus between the two terms. Okay. Now you might be saying, what? Here's a better example. Here we have 14k minus 12 minus 3k. Here we have three terms, and let's start combining like terms. Let's start with 14k. 14k are like terms with minus 3k. Okay, those are like terms. Now combine them. 14 minus 3 gives you 11. And what is our variable part? It's k. Now since minus 12 we didn't touch it, we just bring it down. So we have 11k minus 12. As see, if you don't touch it, you just bring it down. But if you touch all of it, you're left without a sign, right? The sign you're going to use between the terms will be addition. Now, basically, simple. Now, let's get to the gist of it. Here's the main idea of this whole section. Basically, simplifying variable expression means that we're combining all the like terms we can find. Okay, that's basically it, and that's what we're basically doing. So let's try this: 12x plus 3z minus 9x plus 4y minus 3z minus 3y plus 7. I want you guys to try this on your own. Pause the video and try if you can see if you're able to do this. Okay. Okay. Hopefully you pause the video. If not, pause again, then try it. But now, let's try this together. Here we have how many terms? 1, 2, 3, 4, 5, 6, 7. We have 7 terms. Now we're trying to simplify this. So that means we're going to look for like terms, then combine them, and then rewrite the expression. So let's start with 12x. Okay. Is there any like terms with 12x? Yes, it's minus 9x. So those two are like terms. Now let's move on to plus 3z. Is there any like terms with plus 3z? Yes, it's minus 3z. Those two are like terms. We know 9, this is like terms with this. So let's move on to the next one, 4y. Is there any like terms with 4y? Yes, it's minus 3y. And then last but not least, 7. Does 7 have a like term? No. So that's it. Those are all like term pairs. Now what we do is we combine them. Let's start with the first pair. 12x minus 9. So let's combine them. 12 minus 9 gives you 3x. Okay. Now moving on, we have 3z minus 3z. Okay. So 3 minus 3 gives you 0z. And you put addition. Okay. Now let's move on to the next like term, 4y minus 3y, and that is 4 minus 3 gives you 1, and then we copy the term y, the variable part I mean, and then we just bring down plus 7. So you might give me this as your answer already, but once again you can make it look a bit nicer. Here we have 3x, so we can leave it as is. Now here's the thing, 0, z. My question is, do you guys remember the operation between 0 and z? It's multiplication, okay? You're multiplying 0 and z together. And do you guys remember, or do you guys know what happens when you multiply anything with 0? You get 0. So 0z, 0 times z gives you 0. So you don't need to put 0z, okay? This gives you 0. So you don't need to put plus 0. Now let's move on to the next one. 1y. Do you guys remember the identity property? 1 times y is y. So we can write this as plus y. And then, can we do anything else with 7? No. So that's it. Bring it down. So your final answer is supposed to be 3x plus y plus 7. So why this? Why not just leave it as 1y? Because I want you guys to get in the habit that when you see this, you automatically think this, okay? Because if you guys get used to writing 1y, once you see this, you'll be lost. Like, what's that? Is it 0y? It's 1y, okay? Any questions? Now here's the last part. This one's supposed to be for distributing, for the distributive property, but I kind of forgot about it. So let's talk about multiplying a number with a variable term, okay? So here we have a number 4, and we're multiplying that with 5x. So before that, let me ask you, what is the operation of the parentheses again? What are we doing with 4 and 5x? We're multiplying, right? So essentially we're multiplying 4 times, and then what is the operation? What are we doing with 5 and x? Are we adding them, subtracting them, multiplying them, dividing them? We're multiplying them. So we have 4 times on the outside, and we have 5 times x on the inside. Now, do you guys remember the property of multiplication that allows us to move the parentheses around? Sorry about that. It is associative property. So associative property says we can change this into 4 times 5 times x. 4 times 5 times x gives you 20 times x, or 20x, okay? And that's it. So basically, what you're doing is you're multiplying the number outside with the coefficient, okay? You don't need to show me this. You can just go all from here to straight to the answer. So let's try some example. We have 2 times 8x, that is 16x. Here we have 4 times 3y, that's 12y. And last but not least, we have 6 times 2z, and that is 12z. And that's it. And that's it for this video. Hopefully you guys got the lesson. If you do have questions, you can just email me. And that's it for today. I'll see you again on the next video. Bye.